Watershed delineation. A watershed is an area of land that drains all the streams and rainfall to a common outlet, which may be a reservoir, a bay, or any point along a stream channel. Now we will understand how this is done in QGIS. First, add the raster dem file, and this has the extension of TIFF. Open it and add it. Now you will see the dem file. Now go to the, you can check in the properties. There you will see the unit is given in degrees, and you can also see the coordinate system WGS 84, which is geographic. Now we will do the next process. Go to the bottom left and search for reproject dim. You will select the option warp reproject. Then in this, you will in the input layer, you will put that dim number, and in the target CRS you will browse. In that you will uncheck the box of no CRS. In filter, you will be adding the GS84 UTM number projection, which is UTM zone 43N for this Pune region. It will change depending on your own region. Say OK, and go to the reprojected. In that you will you do not need to save the file of, you can use a temporary file or save to a regular file. In this case we are using temporary file, and you run it. Close the box and you will get the reprojected square in the layer panel. Now we will go next. Again, if you want to check it, you can see that the unit has to be in meters, and it is written there as projected in the CRS. This confirms that it is done correctly. Now again, in that box you go to select the next one, that is the sync. Now in this, what we will be doing is we will be selecting the fill sync Wang and Liu. Once you go to that, you have to check the reprojected the dem file. Now in this we do not need to save a file of flow direction and watershed basin, so you have to uncheck flow direction and watershed basin, and then you run it. ये परत ली थी. Now the task is complete, and we can see that the fill dem has come in the layer panel. Now we will go to the processing algorithms and search for the next uh, thing, that is Strahler order. Now in elevation, you give the filled, you can see the filled dem, and you can save it as a temporary or a file or a regular file. Here we are doing the temporary file and then you just run it. After it is run, you will see on the right side the task will be completed, is shown. Now the task is completed and you also get standard order which is written in the layer panel. You can see that the first stream is of the number 1 and the last one is of 11. Now when you zoom in, you can go to the you can see the streams. If you zoom in, select one of the streams, select the icon I identify feature and click on that. You will see the in the right side that is it is the 10th order stream. Then you have to go, you we will be selecting the feature and we will be marking in layer. We will be adding a new shape file. You know the process of creating a shape file. So go to the new shape file and add the georeferenced WGS 84 EPSG, the number which is for the Pune region 32643, and then once you get this UTM zone 43N, you select the start with toggle editing, add the point feature on that. When you get a feature attribute there, you put the identity 1 and then go to stop editing. Now you will see when you right click on the order 1, you see the attribute table. You can see that the feature, the identified feature, the stream 1, the point 1 can be seen. And in that you go to open field calculator where you can create a new field. You give the output field name as the longitude value and you take it as decimal number. In that decimal number, you will go to the geometry. You give the $x for the value and you will in the preview you can see the number which is the degree decimal number. You say okay. You can see the number in the first order. Go to the next one, again select the output field name as y, select the decimal one, again you go to the same $y. In that you will be able to see the number in the preview. Say okay. Now these two numbers are for x and y, the digital number. You save it, save edits. Now you will go to close this. You have to do the next one, that is the upslope area. Select it from the algorithms in the bottom left corner. Now once you got the algorithm, we will be adding the actual values for the x and y coordinates. You open the attribute table, select those x values, copy it and paste it in the target x, the decimal value. And again, same way, do it for the y1. Copy and paste in the target y coordinate. Now, if you go to elevation, you will have to select the fill dim in that, and in the type of method, you select any one method. You can select the first one, and in the upslope area, you save to a temporary file, and we can run it. Finally, we are arriving at a watershed delineation which we are going to mark in the entire dim. The task is complete. We have executed the task of upslope area, and you can see the outline of the watershed. Now we can check in that. Again, we can go to the next thing where we have to convert it into from raster to vector. So we will, in this processing algorithm, you search for polygonize raster to vector. In the box, look at the upslope area and run it. You can save again to a temporary file. Now if you look at the attribute table of the vectorized file, you have to select the dn value of 0, which is there, and the second one has 100, the first one has 100. You select the 0 one, and we have to delete it because we want only the main delineated part. You save edits, and then if you close this box, you can see, you if you see the vectorized map, you can, which appears on your map on your screen. If you look at the properties in the symbology, you can make various changes in that based on what you require, like the simple outline in blue color. And you, this is the final map which shows the watershed delineation. The process is complete.